Alright guys, we're going to start off with chapter 3a, and we're going to start actually in the middle of the chapter with 3-5, and we're going to talk about slopes of lines. Before we get to that, we're going to talk about our math humor. Why is the angle formed by two perpendicular lines never wrong?
Well, because it's always right.
Oh, ding ding. Cheesy. So we're taking a look at the slope of the line. You've run through this before in your previous math classes, so it should be a review. So when we talk about a slope, it's got two components. First off, we're going to talk about the rise, and the rise is actually just the difference in the y values. It's how much you travel up. So in the example they have on the side, the rise is 6 because it's going to travel, the line travels up 6 units, and then the run is how much it travels along the x direction, so either left or right. So that means in this case, after we rose 6 units, we traveled right 4 units, so my run was a positive 4. So when we take our slope is actually just our rise over our run. And when we find our rise, it's y2 minus y1, our run is x2 minus x1, and those come from the coordinates of the points on the line. So our slope, make sure you know this formula. We will not give you this formula right here. You have to know it. So using the knowledge that we just covered with the slopes, we're going to have you find the slopes for the following lines. I'm going to run through one with you, and then you're going to try the other ones on your own. So if we take a look at the first one, line AB, if I take a look at AB, so if we take a look then at the point A, we're going to come up with the coordinates situated at -2, 7, and point B is situated at 3, 7. So if we're going to find the slope of this line, what we're going to do is we're going to do y2 minus y1. My y2, if you want to label them, you can, but my y2 is 7, and my y1 is going to be 7 also. So we're going to do 7 minus 7 over, and then since I started off with the point B as my x2, y2, we're going to take x2, which is 3, minus x1, which is a -2. So I get 3 minus a -2. So solving this, 7 minus 7 gives me that 0 over a 5, and 0 divided by anything ends up being 0. So the slope of line AB is 0. Why don't you go ahead and try out the next couple lines, figure out what the answers are, and then come back to us when you have them. So taking a look, then we're going to look at the line AC and its slope, and hopefully you ended up getting a -5, 6, and that makes sense because when we take a look at the line AC, that is indeed a line that has a negative slope, and we'll talk about that in a second. AD, hopefully you saw that when you found the slope for AD, you ended up getting 6 divided by 0, and when you do that, when you divide by 0, you can't divide by 0, so we call it an undefined slope. And when you're looking at AD, keep this in mind, it is indeed a vertical line, and its slope was undefined. Next, CD, when you find the slope for CD, I ended up getting a 1/6 for my slope, and it makes sense because it's a slowly, gradually positive slope to that line. So when talking about the different types of lines with their slopes, if we look at a positive slope, the positive slope, it's a line that's rising from the left to the right, it's going up. If I have a line that has a negative slope, we say it's falling, so from left to right, the values of that line are getting smaller. If I'm working with a horizontal lines always have 0 for the slope. Don't say no slope, it is 0. For the slope, 0 is a number. And then the last one is for a vertical line, the slope is undefined. So remember that, vertical line is undefined for its slope. So what if we give you an example and I ask you to graph the line that has a slope of 2/5 and it passes through the point 1, 2. First step we're going to do is we're going to go ahead and plot the point. So I want you to plot the point 1, 2, which means starting at the origin, you're going to do your x coordinate first. So you're going to move right or left. Well, in this case, you're going to move right 1 unit, and then you're going to move up 2 units. So if I move right 1 unit and up 2 units, we'll be sitting there with my point. That's point P. Next, it says we're going to go ahead and graph the line that has a slope of 2/5. So if I have a slope of 2/5, slope is rise over run. So this is telling me that I should actually be moving up 2 units from my original point, and then the 5 is telling me that I should move right 5 units. So from my point P, we're going to go up 2 units and then right 5 units. and I'm going to plot my point. Now, if I did that, I could also, in case you picked up on this, 2/5 is the same thing as, you could say it's the same thing as a -2 over a -5 due to the fact that the negatives would cancel. So I could also actually go down 2 units and left 5 units and plot another point. Let me find my point. There we go. So then all we do is draw the straightest possible line we can do on this, and bonus. There's our line.
Redo.
So we're going to take a look at a real-world example for slope. We're going to talk about Justin. He is driving from home to his college dorm, and at 4 p.m. he is 260 miles from home, and at 7 p.m. he is 455 miles from home. And what they've done for us is they've actually graphed it out on this graph, his traveling situation, and it's going to represent the distance. So we've got time and we've got distance that he is away from home, and what we want to do is we want to find the slope of this line and actually interpret what it means. So if we're going to find the slope, we're going to do it just like we were doing before. Finding the slope, we're going to take y2 minus y1, so I'm going to do 455 minus my 260, so 455 minus 260 over my x2 minus my x1. So it's 7 minus 4. And when we do this, we end up getting 195 over 3, which for us reduces down to 65. Now, what does that mean? Well, if we take a look at this, I said before that the values down here represent our time, and our values on the y-axis represent our distance. So we're really working with miles and hours. And if we take the slope, what we have above here is miles, and what we have down here was a change in hours. So we really are working with miles per hour then. So interpreting his slope, we know then that Justin is traveling at 65 miles per hour on average from 4 p.m. to 7 p.m. We're going to use the previous graph then to estimate how far Justin has traveled by 8:30 p.m. if his average speed were to stay the same. So using this graph, 8:30 is really like 8.5. And if I find 8.5 time-wise on my graph looking at the x-axis, I'm going to follow that up and I'm going to try to determine then what the y value would be corresponding to that point. If we find the y value, if I travel over a little bit, it looks to be around 550, 560, if we would say that. And that's telling us that 560, he would be 60 miles away from home at 8:30.
All right, you guys, the next thing that we're going to talk about are parallel lines and perpendicular lines and how their slopes are related. Parallel lines, I do believe we've kind of sort of hit on once before, but these are lines that are coplanar and do not intersect, so they will not run into each other. That means as this line A rises, B also rises the same amount. Otherwise, we end up running into each other. So the rise and the run have to be exactly the same. Otherwise, we end up crossing each other, and then we wouldn't be parallel lines. So the thing that we want to remember on this slide, parallel lines have the exact same slope. So if this line has a slope of 1/2, then this line would also have to have a slope of 1/2.
Nice.
All right, perpendicular lines are a little bit different. Perpendicular lines do not run side by side. They actually run into each other. These are two lines that intersect to form right angles. They cross, and they form a right angle here where they cross. Okay? Our perpendicular lines also have something specific about their slopes. Perpendicular lines have what we call an opposite reciprocal slope, meaning opposite sign. I still can't write. Opposite sign. And you guys should know what the reciprocal of a fraction is. If I give you the fraction 1/2, my reciprocal would be 2/1. Okay? So vertical lines and horizontal lines are also perpendicular. The reason being, well, one's vertical, one's horizontal. And if you think about this, for a vertical line, the slope is undefined, meaning that we'd have some number over 0, and our horizontal line would be 0 over some number here. So we want to remember vertical lines and horizontal lines are perpendicular. We want to remember that perpendicular lines also have opposite reciprocal slopes. All right, so the next three examples, they're going to ask you to graph the pair of lines, then use the slopes to determine if they are parallel, perpendicular, or neither. So our first line is CD. We have the points at -1, -3. So here is C. And then the point 1, 1 for D. Oops. So there's D. And I'm going to try and be cool like Mrs. Kubasek here and draw a nice straight line through. All right. The next line is EF, so I have -1, +1, so that's E. I can't draw points at all. And F is at 0, 3. We'll draw a line through there. So they look like they're parallel, but you can't just assume. You actually have to go through and do the work. So I've got the line CD. We're going to find our slope. And we've got the line EF. We're going to find our slope. We're going to compare them. And then we're going to see if they are the same, if they're opposite reciprocals, or if they're just completely different. So, for CD, if we do our y2 minus y1, we have 1 minus a -3. x2 minus x1 is 1 minus a -1. We end up with 4 over 2, which is a slope of 2 over 1. Okay, for EF, I've got 3 minus 1. All over 0 minus a -1, which also gives me 2 over 1. Let's take a look at the slopes. Are the slopes the same, opposite reciprocals, or neither? Hopefully, you said that these are the same, and we just learned parallel lines have the same slope, so these lines are going to be parallel. What I would like for you to do is do this next one, and then we're going to come back and talk about them. Okay, so you're going to graph the line GH, IJ, you're going to find the slopes, and then you're going to tell me if they're parallel, perpendicular, or neither. All right, what you guys should have done is graph the line. Here's GH, and then here is IJ. They kind of look like they might be perpendicular, but of course you had to go through and do the math. Your slope for GH was 1. Your slope for, IJ was -2. These are not even close to being the same number, so therefore these are neither. They are not perpendicular or parallel. All right, again, I would like for you to graph the lines, find the slopes, and tell me if they're parallel, perpendicular, or neither. All right, you guys, what you should have noticed is that when you graph this, WX ends up being a vertical line, so the slope ends up being undefined. And YZ is a horizontal line, so the slope ends up being 0. We talked about this. Horizontal lines and vertical lines will always be perpendicular. Make sure you guys do your whisk, and we'll see you guys tomorrow.